you didn't get something down or you want to re-look at it with my guidance. So we want to solve for x in this problem. So to solve for x, we obviously need to get everything on the other side. So to get rid of that, we subtract 4y from both sides and we get 9x equals 19 minus 4y. You could put negative 4y plus 19. Either way is fine with me. And then divide by 9. So we get x equals 19 minus 4y all over 9. And then I say solve for y. So we can go to our original equation, and we're going to subtract the 9x from both sides instead. And then divide by 4. So it's the same process as the one above, but instead we want to get y alone. For this problem, we want to solve for a. So I know that I can't do anything to the numerator in a fraction. There's nothing you can do. So we want to be able to get rid of the denominator. To get rid of the denominator, we multiply both sides by 2a. So I'll have 4b plus 5 equals 2 times 19 is 38a. Now I want a alone, so I'll divide by 38. 4b plus 5 divided by 38 gives me my a. And like I said in class, we are not solving in a numerical sense. We're solving an equation for these type of problems. There's no way we can solve this when we don't know what b is. So it's just getting it into an equation that would make it easy if we knew what b was to plug it in and go. Now it says solve for b. So I said in class, instead of going all the way back and multiplying both sides by a, I could just look at this equation. And I see I have to subtract 5 over, so I have 4b equals 38a minus 5, and then divide by 4. We get b equals 38a minus 5 divided by 4. And that would be my answer for our b. Now we are going, once again, we're solving for variables, but we're going to use this and apply it to other problems. So I want to solve for x. So normally, like we do, we subtract or add. In this case, we're going to subtract over b because there's an addition sign. So I get ax equals c minus b. Then I divide both sides by a. So I get x equals c minus b divided by a. Then it says, then use this solution to solve 2x plus 5 equals 11. Well, you're like, Miss Pollard, that's so simple. Subtract 5, divide by 2. Well, on the quiz, I am going to make you use this formula. So you have to know how to do this. So we look. A is here. A is here. 2 is going to be our A in this problem. Then we have B as 5 because it's in the B spot, and C as 11. So I'm going to write x equals 11 minus 5 all over 2. 11 minus 5 is 6, divided by 2 is 3, which if we solved that normally we would have gotten, but I need to see you plug in your answers in the correct spots. Solve for x, and ax equals bx plus c. So this is the one that gave us a little bit of challenge here. So every time we have a problem like this where we see multiple terms having our variable that we're solving for, you want to move them all to the same side. So that meaning I'm going to move over bx. So do that, I get ax minus bx equals c. Now we want to leave x alone. We need to get it by itself. So I'm going to factor out an x from each term. So I get x, I took out an x, and I'm left with an a. I took out an x, I'm left with a minus b equals c. Still, I don't have x alone. I have it multiplied by a minus b. So I'm going to divide both sides by a minus b, and that's my final answer. Now I'm going to use this to solve 11x equals 6x plus 20. So my c is the 20 from our equation up above, over my a is 11 because it's in the a spot, minus my b, which is 6. So we get 20 divided by 5, which gives me x equals 4. Once again, you could have solved that normally, but on the quiz, I need to see that you're able to plug in and you know which ones go with which. Now we want to solve for p. So once again, we want to get only the ones that have our variable we're solving for on the one side. So we have to subtract the 9 over. I know that looks like a G, it's a 9. So we have R minus 9 equals JP minus KP. Do what we did for the last problem. R minus 9, take out a P. And then we finish it off. I'll move up here just so we have room for the others. And I get R minus 9, that's an R, divided by J minus K, because we want to get rid of the stuff that's attached to the P, equals P. Now we want to solve for Y. Like I said before, you cannot do anything with the numerator until the denominator is multiplied over. So we'll have 9Y plus 4 equals 7S, 4P plus 1. We're solving for Y, so we have to subtract the 4 over. And like I said in class, you cannot put the 4, the minus 4, inside the parentheses. You can't combine stuff that's in parentheses with outside of parentheses. So you just throw it on the end. We just want Y, so we divide by 9. And that long thing will be our final answer. My stylus is not writing anymore. It's going crazy. All over 9. Now finally, we're going to solve for R. So I'm going to use the techniques we did last class to show that if we have a number 4/3, we have to multiply by the reciprocal to get rid of that rather than distributing in. That gives fractions. We don't like fractions as much. So we multiply by the reciprocal, which is 3/4. So we have 4R plus 3S. 8 times 3 divided by 2 is 6 with our A. We're solving for R, so subtract over the 3S and then divide by 4. 6A minus 3S all over 4. And that would be my final answer. You could break it up to make it 6 over 4A minus 3S over 4, but why cause any other step of error when you can just keep it like that, which I suggest. All right, once again, we want to solve for X. So I am going to factor out an X. Well, both terms have an X in it, so we factor it out, and we get 3 plus 5Z. A lot of us thought, oh, we can add the 3 and the 5. No, they are not common terms. So we're going to leave them separately, and then we divide it over. So we get Y divided by 3 plus 5Z. Make sure it's all under equals X. I'm sorry, that was really sloppy. It says Y over 3 plus 5Z equals X. Now we have the surface area as that formula, and we want to solve for our L. So if we do that, we see we have this extra term here that has no L on it. We're going to move that over so we have just terms of L. So we have S minus 2WH equals 2LW plus 2LH. Like I said in class, it's very hard to draw those L's. They look like parentheses, but they're not. Now we want to take out an L. So that's what we're trying to look for. Equals L 2W plus 2H. And to get L alone, we divide over. So I can write this up here a little bit. Ooh. My computer always acts up. So we get S minus 2WH divided by 2W plus 2H equals L. And I got asked in class, do I have to keep the parentheses on the denominator? No, you can totally do it just for your own sanity. But if you don't want to keep the parentheses, that's fine. Just make sure the line extends fully under or over it so you don't get confused of, is that under the fraction? Is it not? All right, now we want to solve for A. So first, you can't just multiply over A because we still have that negative F. So we're going to add F over, and we get B divided by A equals T cubed plus F. Now we want to multiply A over, and we get A. You have to have that parentheses because you're not just multiplying A by T to the third. You're multiplying it by both terms. And then we want A alone, so we divide this over. This is a B. And we get our A. Next type of problem, same stuff as we've been doing. we have to get A alone, so I add G over. So I get 6 plus G equals 1/5 RA. I'm going to multiply both sides by 5. And then divide by R. If you wanted to do that all in one step, let me finish writing this. If I wanted to just do, I know this is multiplied by 5, this is divided by 4. I could have done that in one step. That's fine with me, as long as you get the correct answer, of course. But I just want to make sure that we're all getting the correct answer. So if you need to split it up, perfectly fine. If you think you're good, you do not have to. Now we want to solve the following equation for B. And we can ignore the rest of the words. We're just going to keep doing what we usually do. So I'm going to add F to both sides. So I get 3G plus F equals DB squared. I want B alone, so I divide by D. Then we saw in class that the reciprocal for squared is square rooting. We've heard the word reciprocal before, but a lot of us were confused about the square and square rooting. So to undo a square, to get rid of it, we square root it on both sides. So we get B equals the square root of 3, let me write this smaller, 3G plus F all over D. These are reciprocals of each other. They cancel out. So that gets the B alone, that gets the square root. Typically, we would have wrote a B on the right and this stuff on the left. It's okay either way, just so you know B equals this. I'm used to writing it left to right, but I can see where that can be a confusion. So as long as you have this, it doesn't matter which side they're on. Now we want to solve for A in this problem. So like I said before, square roots and squaring are reciprocals of each other. So you cannot do anything inside the square root until you get rid of it. It's just like parentheses. You can't move something out of parentheses until you get rid of the thing that's attached to it. So to get rid of the square root, we're going to square both sides. So I'll get m squared equals 3dA plus f. It gets rid of the square root. It's gone. It squares the left side, keeps the right under the radical the same. Now we keep going like we normally would. M squared minus f equals 3dA. I subtracted f from both sides. And I want a alone. So I can see that the 3d is attached to it, so I'm going to divide by 3d. Like I said before, you can separate both of them. You can divide by 3, then divide by d. Perfectly fine with me. But if you're able to see, oh, 3d needs to go, let's just divide it at one time. I would do this first, do the 3d together first, where compared to the other one, I split it up and did the 1/5 reciprocal first and then the other number dividing, because those were two different operations. I was multiplying, then dividing. Here, I'm just dividing, so it's okay if I do it all at once. The other way, like I said, is okay. I don't know, it's just personal preference, and I'm babbling on. Finally, we have our word problem. So our equation is C equals 5/9, right? Make sure. Yep, 5/9. F minus 32. And I told you guys that whenever I give you a problem with the weather, I'll give you this formula, and then you need to multiply over and add over and do whatever you have to do to get F alone. So we're going to multiply both sides by 9/5. And then we add 32. So 9/5 C plus 32 equals F. And that's our formula for finding degrees Fahrenheit. But now I want to find what the Saturday low would be in Fahrenheit, given that I have 14 degrees Celsius. So I'm going to plug that in for C. And when I do that, I get a decimal. Let me plug this into my calculator. Do 9 times 14 divided by 5 plus 32 gives me 57.2 degrees Fahrenheit. If you do not write degrees Fahrenheit, I am taking points off. I want you to be very specific, degrees Fahrenheit. And then if I do the Sunday low, I would do 9 times 10, which is 90, divided by 5 gives me 18, plus 32 gives me 50. So this one is going to be 50 degrees Fahrenheit. Just plug the 10 in instead. So if you have any questions You can email me, of course, always email me. But I have extra help on Wednesday, so email me so I know you're coming. You can come and work on consecutive integers. You can come work on our literal equations. And if you are feeling fine and then you come to class Thursday and we do our review and you're not feeling as strong, I can stay on Thursday. You're just gonna have to let me know so I don't go home. And we have a quiz Monday on basic solving equations. There's not gonna be many of those, but definitely consecutive integers and literal equations.